Thanks very much. It's a pleasure to be here. I really appreciate the invitation. I was asked to talk about biomass. That's what it says on our schedules, but actually I interpret that to mean exposure to smoke from the combustion of biomass materials. Now, even though that's my topic, I'm actually going to enter that discussion through a discussion of particulate matter more generally, since we know a lot more about particulate matter exposures, and we know less about biomass combustion smoke exposures with respect to lung cancer. So we'll talk a little bit about PM and health effects generally, and then more specifically about PM exposures and lung cancer risk. And even touching upon very briefly questions of mechanisms, although I won't have a whole lot of time to delve into that. And then finally, talk about a particular occupational group that may be of particular interest for lung cancer screening. So for starters, those of us that work on air pollution and epidemiology, I like to point to this particular data point from the Global Burden of Disease study. So this is looking at rankings of contributing factors to global disability adjusted life years. And you can see that particulate matter air pollution, this is what they call sort of level 2 look at things. The level 1s are this color coded according to environmental occupational risks in the red, metabolic risks in the green, and behavioral risks in the blue. So among these, I just pictured the top 10 in this figure, but particulate matter air pollution is and has been for quite a while leading the way in terms of overall disability adjusted life years. That, as you can imagine, is not because of lung cancer mortality. It's from other things, and predominantly it's from cardiovascular and cardiopulmonary morbidity and mortality. I wanted to show this figure. It's called an integrated exposure response curve, and it's a useful visual for us to look at smoking exposures and other types of particulate matter exposures on a scales, and we can look also at how each of those exposures relate to risk. So the vertical axis is hazard ratios for cardiopulmonary mortality, and the horizontal axis is presenting different sets of study populations according to their estimated daily exposure of PM 2.5, including smokers who do have an exposure to smoke, combustion of smoke, or excuse me, combustion of biomass. This does ignore the different toxicities associated with these exposures. So I don't want to overinterpret this, right? Obviously, the chemical composition of tobacco smoke is different than the chemical composition of PM 2.5 in the ambient air that we breathe in a variety of settings. Nevertheless, what we can see here is that, I should also say this is logged, the exposure axis is logged because the exposures to direct smoking is so high. But this log linear relationship holds true all the way from the very high end of heavy smokers and down to very light smokers, and then ultimately down to secondhand or environmental tobacco smoke, and then on down to air pollution exposures, which in terms of exposure concentrations overlaps with some ambient environments. I'll also point you to, in the parentheticals, or the parentheses numbers on that horizontal axis, those are estimates of concentration of PM 2.5. So, and then what I did here is, just for fun, I overlaid just to help us orient around the different types of concentrations of exposure that we might have. The US studies that are selected here on the left, China studies are those in green. And so the difference between US exposures in these studies and China studies are anywhere from like about 20 microgram per cubic meter to around 40 microgram per cubic meter. Residential wood combustion is somewhere in between. That's an environment that I'm very familiar with. Household air pollution, we'll hear about that in a moment. And then at the very end, I'm going to talk about wildland firefighter exposures. Okay, what about lung cancer risk? Well, lung cancer risk, there's been lots of studies on air pollution exposure and lung cancer risk. This is just a meta-analysis. The overall estimate is here. Well, you can see the random effects meta, the random effects meta estimates around 1.13 or 13% increase in lung cancer mortality for every 10 microgram per cubic meter increase in particulate matter exposure for ambient exposures. And I'm going to skip past these mechanisms. We can talk about them later. But there's everything from general mechanisms to more recent specific mechanisms that have been investigated more recently with respect to air pollution exposure and lung cancer risk. So finally, I want to turn to an occupational group that is of interest with respect to biomass exposure. And there was a recent study by the group at Rush that investigated structural firefighters through a local union. They looked at 1,300 firefighters that underwent LDCT. Of those, only 6.6% of those firefighters were eligible per lung cancer screening guideline, current lung cancer screening guidelines. They used the lung-RANS 3 and 4 as 3 and 4 nodules as a proxy to quantify lung cancer risk. So here's what they found. And first, I want to point you to this, the smoking status. So 2/3 of this group were never smokers, which is pretty interesting. You can see if we look at just a non-screening eligible group, there was, and looking at lung-RANS 3 and 4, there was 45 lung-RANS 3 and 4 among that group. That includes a lot of non-smokers that were not eligible for lung cancer screening. Looking now, this is just among that group that was not eligible for lung cancer screening, and splitting them into never smokers versus current and former smokers, and then looking at the occurrence of lung-RANS 3 and 4 according to years of firefighting experience. And you can see that that there, in percentage-wise, at least, there is increasing findings of lung-RANS 3 and 4, including among the never smokers, as increased based on increasing years of exposure. Now, what are they exposed to? Well, they are exposed to particulate matter. They're also exposed to lots of other things, then including carcinogens when they're exposed to structural firefighting. Okay, last point here. And I wish I had more time to get into this, but I think that this is a particularly interesting occupational group to follow in the future, which are firefighters that are engaged in fighting wildland fires. For a variety of reasons, I think this is important. One, there's increased attention to the health of wildland firefighters. There was recently a series of articles in the New York Times about this. They are exposed to extremely high particulate matter concentrations when they're actively engaged in firefighting. They're exposed to carcinogens. You can think of smoke as a vehicle for the delivery of things like polycyclic aromatic hydrocarbons. And unlike structural firefighters, they do not wear protection against inhalation exposures.